Hello and welcome back to the channel Understanding Concepts of Physics. In case you haven't subscribed my channel, kindly do so and keep following for the future updates. Yesterday we had discussed about first law of thermodynamics. We are in the previous video, first law of thermodynamics, pretty in detail, and you can just go and watch those videos. Today we are going to discuss some more topics. The first is what are state variables and its types, state variables and types, and we are also going to discuss about equilibrium and its type. So equilibrium and types. So let's get quickly started with these two videos, these two concepts. So first foremost, state variables. Let's understand what the definition has to say. Any measurable quantity, so that has to be a measurable quantity which you can measure, which describes the state of the system. So what kind of state of the system is. Now here we are not talking of the states of matter, but we are talking about the state. How is it going to define the system is called as the state variable. So any measurable quantity that describes the state of a system is called as the state variable. So sir, let's say suppose I have this one system of and this is another system, let's say in orange. Okay, so there is some gas in this and there is some other gas in this. Okay, so this might be having some pressure P1, this might be having some volume V1, this might be having a temperature T1, and this gas might be having some pressure P2, volume V2, temperature T2. So you see, when I say that this gas, this one with the red mark, now this container, the first container, now this container is having some amount of pressure, volume and temperature. So these pressure, volume and temperature is kind of describing the system, okay, how much the pressure is, how much the volume is, and how much the temperature. And this is not the only variables. We can also add few more variables, the density of that, the density of a particular gas. We can add mass of the gas. Whatever quantity is used in order to describe a system is what is called as a state variable. So this is what is called as a state variable, so which is describing the state. Okay, so if you have another system like this second system, there might be different pressure, there might be different volume, there might be different temperature, the density might be different, the mass might be different, the molar mass of the gas might be different. So what is happening is, okay, the quantity, that measurable quantity which is describing the state of the gas, what kind of gas is in state of, is what is called as the state variables. So any measurable quantity that describes the state of a system is called as the state variables. Now for few examples I have given: pressure, volume, temperature, density, mass, all these are called as the state variables. Now quickly we'll understand what are types of state variables. So there are two types of state variables. One is called as an intensive variables, and the other is called as an extensive variable. So there is an intensive and the extensive. So those variables which do not depend on the size are called as intensive variables. So if there is a system on which there are some variables, pressure, volume, temperature, density, mass, and whichever you have, then if those variables are independent of size, they are not dependent on size, then those are called as the intensive variables. Okay, so if you can read this, the variables which do not depend on the size of the system are called as intensive variables. So the variables which do not depend on the size of the system is called as the intensive variable. So for example, density, for example, temperature. These are the variables which do not depend on the size of the system. So for example, let's say I'm taking a container. I'm taking a container here, and this container has some gas. So these are the gas molecules. Okay. Now what happens is, okay, suppose if I suddenly divide this container into two. Suppose if I divide this container into two, something like this. Okay, two equal parts. Okay, two equal parts. Now what is going to happen? I have just given an example of density. So the density of the entire gas will not change if I divide the container into two. So even if I divided the container into two, if I put a partition in between, the density in this side and the density on this side of the container will remain same. That means the density is not depending on the size of the system. That's why it is called as an intensive variable. Same it goes for temperature as well. If the temperature of the entire container was, let's say, 20 degrees Celsius, now if I am putting a partition will not change the temperature. The both sides will have 20 degrees Celsius ka temperature. It implies that the system, these variable like temperature, the density, does not depend on the size of the system. Even if I have made the system part in two, still the variables has not changed. The temperature remains the same, the density remains the same. So such kind of variables, we can say that these are the intensive variables. Now we come to the extensive variable, exactly opposite of that. Now what is this? Let's try to understand. It's exactly opposite of what is called as the intensive variable. So extensive variable is basically those variables which depend on the size of the system is called as an extensive variable. So those variables which depend on the size are called as an extensive variables, and those variables which do not depend on size is called as an intensive variable. So you can just club it into two. Okay, this is your intensive and this is your extensive. An intensive variable does not depend on size, and extensive variable depend on size. So this is the way how we do it. So let's take some examples of this, like mass and volume. So if you see this thing, now if the mass of the entire gas is, let's say, 50 grams, now if I have put a partition, then this is going to become 25 grams and this is going to become 25 grams. That means the mass has been divided into two parts. So yes, the mass is depending on the size of the system, mass has become halved, so mass is an extensive variable. However, when we say let's say volume, so the entire volume, let's say if it was 1 meter cube, now because there is a partition, you will have 0.5 meter cube here, here is 0.5 meter cube, and here it will be 0.5 meter cube. So what is happening is the volume is depending on the size of the system. That's why volume is an extensive variable, and even the mass is also an extensive variable. So any variable which is depending on the size is extensive, and any variable which does not depend on size is an intensive variable. So this is all about variables. Now let's go to something called as thermodynamic equilibrium. Now a system is said to be in thermodynamic equilibrium if it is in mechanical, if it is in chemical, and in thermal equilibrium simultaneously. So basically there are three types of equilibrium, and if a system is in all three of them, then you can say that the system is in thermodynamic equilibrium. So a system is said to be in thermodynamic equilibrium if it is in mechanical, chemical, and thermal equilibrium. So all three equilibrium simultaneously. So let's quickly jump on to what are the types of equilibrium. So there are three types of equilibrium, as you know. The first is mechanical equilibrium, the second is chemical equilibrium, and the third is the thermal equilibrium. So let's guys quickly do it. So when there are no unbalanced forces between a system and the surrounding, then the system is said to be in a mechanical equilibrium. So when there is no unbalanced forces on the system, then the system is said to be in a mechanical equilibrium. So now force, if we are talking about force, we cannot avoid pressure. So if the force is not there, definitely the pressure will remain constant and there will be no change in pressure. I'll give you an example for this. See, suppose in case I have this container, and there is some piston here, aligned a piston. Okay, now if there is no pressure on the upward, or maybe the pressure is constant, the pressure is not acting on both, the pressure is acting on both the sides, like the pressure, atmospheric pressure on this side and the pressure on this side is same. So the net pressure acting on the piston is equal, it's a constant. So the piston is not going to go up, neither it is going to come down. So there is no net external force. So if there is no external force, then the system is called as in a mechanical equilibrium. So we have understood what mechanical equilibrium is. So if there is no external, there is no unbalanced forces, even if it is like, even if the pressure is acting on the from the inside and the force is acting on the upward side, like this, and the piston is moving up, then we cannot say that the system is in mechanical equilibrium. So for mechanical equilibrium, the net unbalanced force should be 0. The upward pressure should be equal to the downward pressure. The piston should not move. That means the pressure has to be constant on both the sides of the piston. So that's why we call as mechanical equilibrium. Next is called as the chemical equilibrium. So let's say if we have some gas and it is going to react with some there is some chemical reaction going inside the gas, then we say that there is an inequilibrium. So if there is no chemical reaction going inside the gas, then we say that the system is in chemical equilibrium. So you don't need any chemical reaction. There is no chemical reactions within the system, then it is said to be in a chemical equilibrium. Now in a chemical equilibrium, there is no exchange of matter taking place. So matter is not getting exchanged. That's where the things are remaining same. Then comes something called as thermal equilibrium, which we have discussed in previous videos and many videos actually. Thermal equilibrium is when there is no exchange of heat energy. So when the heat energy is not exchanged within the system, then it is said to be in a thermal equilibrium. Basically, the temperature of the body should not change. The temperature, if it is constant, like suppose in this case, the temperature is 20 degrees Celsius and maintained at 20 degrees Celsius, then the system is said to be in thermal equilibrium. So there should not be any heat exchange. Now, so if the body is in mechanical equilibrium, if the body is in chemical equilibrium, if the body is in thermal equilibrium, then we say that when all these three conditions are satisfied, we say that the body is in thermodynamic equilibrium. So this is this is what thermodynamic equilibrium is, and all the types of equilibrium, and all about variables and types of variables. So today we are going to wind up on this video. Thank you so much for watching. Subscribe the channel in case you haven't done so, and keep following. Thank you so much. Bye.